The topic is soil mechanics. In the topic compaction of soil. What is compaction? Need for compaction of soil, objectives of compaction, mechanism of compaction, factors affecting compaction, theory of compaction, effect of compaction on soil properties, field compaction control and consolidation. Compaction is the process of increasing the bulk density of soil or aggregate by driving out air. For any soil at a given compact effort, the density obtained depends on the moisture content. An optimum moisture content exists at which it will achieve a maximum density. Compaction is the method of mechanically increasing the density of soil. The densification of soil is achieved by reducing air void space. During compaction, air content reduced but not water content. It is not possible to compact saturated soil. It should be noted that higher the density of soil mass, stronger, stiffer, more durable will be the soil mass. Soil densification include compaction and consolidation. Densification is referred as compaction plus consolidation. Compaction is one kind of densification that is realized by rearrangement of soil particles without outflow of water. It is realized by application of mechanical energy. It does not involve fluid flow but with moisture changing. Consolidation is another kind of densification with fluid flow away. Consolidation is primarily for clay soils. Water is squeezed out from its pores under load. What is compaction? A simple ground improvement technique where the soil is densified through external compactive effort. That is the compactive effort. The compactive effort, the first figure says that without water. After adding the water, the soil particles and this water will be added, then it will form as a dense form. So the soil compaction, the process, soil particles artificially rearranged, packed to a closer state by mechanical means. That is the soil particles, water and air. It's non-compacted, the first figure, and second figure is the compacted after adding the water. The compaction, soil compaction will forms into reduction in volume of soil, expulsion of pore spaces, increase in dry density. Objectives of compaction: increase the shear strength, increase the bearing capacity for foundation support, reduce compressibility and smaller settlement of buildings and lesser deformation, reduce permeability leading to less seepage of water, improve stability and lower damage due to frost action. Heavy highway with building foundation compaction operations to reduce the degree of shrinkage and formation of cracks on drying. Applications of compaction: compaction of foundation, soil for house construction, compaction of soil, gravel, crushed rock, asphalt in road and pavement construction, compaction of soil in earth embankments, compaction of soil behind retaining walls, compaction of soil backfill in trenches, dam construction, construction of clay liners for waste storage areas, ground improvement. Mechanism of compaction: optimum moisture content is the moisture content at which the maximum possible dry density is achieved for a particular compaction energy or compaction method. The corresponding dry density is called maximum dry density. Water is added to lubricate the contact surfaces of soil particles and improve the compressibility of the soil matrix. It should be noted that increase in water content increases the dry density in most soils up to one stage, that is the dry side. Water acts as a lubrication. Behind this level, any further increase in water, that is wet side, will only add more void space, thereby reducing the dry density. Hence, OMC indicates the boundary between the dry side and wet side. Hence, the compaction curve is shown in figure. So, this is a compaction curve. From lubrication and reduction up to the maximum content, that is called as a maximum dry density, that is called as a optimum moisture content after adding the water, then it will be reduced, that is the saturation. So soil behavior under compaction: this is a large porous and small porous after adding the waters and compaction. The compaction methods are two types: one is field compaction and laboratory compaction. That is in field compaction, rolling, ramming and vibration. In laboratory compaction, Proctor compaction, modified Proctor compaction. Coarse grained soils and fine grained soils for laboratory is using vibrating hammer in fine grained soils, falling weight and hammers, needing compactors and static loading and press. That's in field for coarse grained soils are hand operated vibration plates, motorized vibratory rollers, rubber tired equipment, and free falling weight, that is dynamic compaction. Here for field in fine grained soils, hand operated dampers, seep foot rollers, rubber tired rollers. Then the basic theory of the Proctor compaction. The four variables normally we are seeing: compaction efforts, soil types, water content, dry unit weight. Laboratory compaction test are standard Proctor test, modified Proctor test, dated compaction, Harvard miniature compaction. So this is a standard Proctor test equipment normally we are using in the laboratory, and this right side figure is in the we are using the compaction by using the hammer. Then what is consolidation? Consolidation is the process of dissipation of excess pore water pressure in a row of time. This figure shows that saturated clay is loaded externally at up to the ground level. The water level is stored. The water is squeezed out the clay over a long time due to the low permeability of the clay. Why consolidation? This leads to the settlements occurring over a long time, that is the time with settlement, which for several years. This is the consolidation process. The pore water, incompressible, and then the skeletal material, voids and solids, that is the initial state. Then after we are adding the water, that is the deformed state, that is water, solid and voids.